Well, hi and welcome to my shop, and I'm working on this battery operated tube radio here. That's what it looks like there. And I was actually just thinking about operating the radio when I remembered these lead wires I trimmed off the back of it, which are now inside this bag here. The wires were shot, the insulation shot. I'll show you that here. As you can see, all the cracking on them. Very badly cracked. So, since those are the wires that bring the power from the batteries into the radio, they can't be in that kind of condition and operate. So, seems a little soon to me to do this, but the way this works is, I believe we've got a that's an antenna wire there. We'll pull all these back. We'll have two wires for the C battery, for the A battery, A battery rather, and we'll have two wires for the B plus, which in this radio I believe is 90 volts. That's correct. So you can see the two 45 volt batteries shown here. They're just connected in series. So you're going to get 90 volts out of those guys. There's the on-off switch. You notice it's a ganged switch. It's actually two switches. And that's why on the back here there's 4 terminals and 4 wires coming along. So this is brown here, and 90 volts red. Okay. So what wires are actually coming out the back here? Well, these ones have to come out. The ones that show connecting to the batteries, they have to come out of the radio. Excuse me. So one each off the switch. Yep, there they are, those two. Have to come out. A ground wire has to come out, and that's this one. And this other one has to come out over here. Here it is here. Shows it coming through past a resistor to ground, through a resistor to the output tube. Yeah, maybe this pin isn't used here, because this shows it going straight to a pin, or coming straight from a pin. Unless we want to think this is incorrect. There's a wire cut in behind there. What is that? What is that? What is that? One more time. What is that? Sorry about the fan noise. Wire cut right there. And look how that wire is on there, the stranded one. It's not put on like like it would have been at the factory. So this one here, ugh, when you look at it like close, you can really see how bad these wires are. Well, that would potentially be a replacement. What do the other ones look like? Stranded wire also. You can see the red insulation is just all cracked. Yeah, if you really wanted to fix this radio up, you really want to replace all that wire. I'm trying to avoid it myself. So, we're just going to have to snip away these two wires for now and clip lead to those points. That's probably the best way to handle this at the moment. I won't put new wires on it just yet. Also, anything that can get us quicker to trying this radio out, because I really want to give it a try. So we're just going to clip these off here. I'll leave a bit of the insulation so I can see which was white and which was black. This ground wire doesn't mean much to us now. This guy, he's marking this location right here. Cut them off like that. Pull it around. Oh yeah, I was going to pull the insulation off, but stuff is it's not going to slide off the wire at all. So I think sometimes the compounds inside the rubbers and the various materials used in the insulations were chemically active enough. Given time, heat, moisture, gamma rays, I don't know. You get a little bit of reacting going on. Maybe certain kinds of gases in the air, pollution. Any of that kind of stuff can, over a long period of time, cause these materials to just change. They just stop being what they were. They're not stable. Okay, so where does that leave us now? I'm thinking quietly here. So we want to, we certainly know which one's the ground. And there's no question about that, how to do that, right onto the chassis. Then we apply 1.4 volts, which is the battery voltage, to the pin with the brown wire. And that's got to be here. So I'm going to try, see if we can't use the DC power supply. Just right over here. 1.4 is set about as low as I can set it. Let's see. The meter on here isn't particularly accurate, so let's see what it really is. .260. That's pretty good. I like that. And 1.5. Whoops. 1.5. When it gets going pretty quick. It's up around here. I'll just make sure anywhere down here. Is it just basically it's going to put out just a little less than the nominal voltage, and that's just perfect. That's just what I want. Now, this is the on-off switch here. So what I'll do is turn off the DC supply so I can't make any mistakes with it. One side goes to ground. Is that the side they show? Just to be absolutely sure. They show the negative side going to ground. Not sure it really matters. Positive side. Switch feels pretty good. Needs a little lubrication there, but okay, it's certainly off. Okay. Put this like this. Now we can do this. Now, ooh, should we hook up a speaker? Or forego that at this point? No, I think we should hook up a speaker. For all we know, the thing is going to work entirely. Now, I pulled out those speaker leads and laughed. What did I do with them? Where did they go? Ooh. I should have left them in. Okay, gotta hunt down what I did with them. Okay, I finally remembered I put them inside the cabinet. Here they are. Yeah, I probably should have just left these. And again, pulling them out, pushing them back in, will probably solve any connection problems that might have been sitting there. Doesn't feel like you can move these too many times before they're going to break. So let's get the speaker. Just use a temporary one here. Okay. I really don't need to hook up a speaker unless I put B+ on it, but that's coming soon anyway, so I'm going to turn this around here. There we go. Now we're going to look for heating up in these tubes, and to do that, I'm going to have to get it dark in here. Okay, that's the light of the computer screen. So, turn on the power supply. Confirm it's running around 1.5 volts. Yeah. Switching on. Excellent. Saw it jump up in the current just a tiny bit, not much. Going into deepest, darkest darkness now. Okay, so I don't see a thing. Maybe that's because it's pitch black. No, I don't see any light at all. And I'm sure you don't either. Okay, let's go back to having that much light. Well, I don't know what to make of that. Let's put on some power here. And let's put on some lights. Okay, so the ammeter over here, you can just barely see it on the camera. Now for fancy camera tricks, here comes a good one. Get a little better view of that meter. It's a little off the zero. It's 1 amp, 2 amp, 3 amp, 4 amp, 5 amp. But the power supply can only put out 2 amps anyway. So, but this is not a very large amount. So if the tubes aren't lighting, why are they taking some power? I'm going to look at them again in the dark here. Once more. I'm sure there's some basic production rule about shooting TV in the dark, but I'm thinking maybe if I look up, I don't see anything. Oh, that's a little disappointing, and also a little stumptifying here. What should we do about this? Let's double check on this current situation here and see if the current really does move. I'm just going to switch it off and see if the meter drops. Down it goes. Put it back on, you can see it pop up. A little more proof, I'll just break open the circuit here. There you can see the meter go down and back up. Could be lighting one of these tubes and not the others. There's a tube in a shield here, I can't see it. You can't see it either, can you? Yeah, so this tube I can't actually see. And I don't think these tubes would ever get warm. There just isn't enough heat from the heater. So I guess we're going to have to test the tubes. That means bringing out the tube tester. Or test them. I guess that's what we better do next before we go any further. That's a logical thing. That's what's next.